I'm going to label u and v, okay? So u is my numerator, that's 7x squared plus x. U prime is going to be 14x plus 1, okay? And then v is going to be x cubed plus x to the 1/2. And then v prime is going to be 3x squared plus 1/2 x to the negative 1/2. All right. Now I'm going to use the rule that says I'm going to do u prime v minus v prime u all over v squared. I'm going to use that rule. It's following the pattern. And so g prime of x, so please don't put an equal sign there because we are finding the derivative. So it is g prime, so don't put x. What I'm asking you not to do is don't put an equal sign there because it's not equal. We're actually doing a derivative here. So if you want to do an arrow, cool, but don't put an equal sign because we are doing derivatives and not the original function. So following the same rules here, I'm going to write first on my piece of paper equals 14x plus 1. That is u prime. I multiply that by my v, which is x cubed plus x to the 1/2. And then minus, it is the derivative of the v, so v prime, so it's 3x squared plus 1/2 x to the negative 1/2. And then I'm going to multiply that by my numerator, 7x squared plus x. And this is all over my denominator, which was x cubed plus square root of x squared. All right, how are we doing so far? Now let's do our multiplications through. So I'm going to do my first set of multiplications. I'm going to multiply these two, and I'm going to get 14x to the 4th. I'm going to multiply these through, and I'm going to get plus 14x raised to, this is 1 plus 1/2, so it's 3 over 2. So x to the 3 over 2. All right. Now I'm going to do this, so I'm going to get plus x cubed. I'm going to do that one, which gives me plus x to the 1/2. Is there anything I can combine in that first grouping? Unfortunately, no. That's unfortunate. Then I'm going to keep moving on to the next grouping. I'm going to do a minus, I'm going to do a parenthesis there. Now when I do this multiplication, I'm going to do these two first, and so I have 3 times 7, which is 21. So 21, adding my exponents to the 4th power. How was that? Doing the next grouping, here I'm going to do 3x squared times x. So it gives me 3x to the 3rd. Then I'm going to multiply these two. Now, what's happening is I'm going to get 7 over 2, which is okay. So plus 7 over 2. On those exponents, I have a negative 1/2 plus 2. So this gives me 3 over 2, 1.5 or 3 over 2. So the exponent is going to be x to the 3 over 2. How are we doing? All right. And then I'm going to do my last one here. So I have plus 1/2, and I'm doing a negative 1/2 on my exponent. So that exponent is a negative 1/2 plus 1, so the exponent is a positive 1/2. Okay? So it ends up becoming x to the positive 1/2. All over, this thing is all over this. So fun and delicious. X cubed plus square root of x, the quantity squared. How are we doing? My numbers good? Okay, so by the magic of marker and the power of grayskull, I'm just going to pull that negative through. There's a negative here, negative here, negative here, and I can take off those parentheses. Now I'm going to look for like terms. I'm going to start with my power of 4. So this one and this one will combine. So 14 minus 21 is negative 7x to the 4th. How was that? You okay so far? I'm going to do my cubes next. So I'm going to pull this one and this one. So 1 minus 3, so that is minus 2x to the 3rd. I'm going to do my x to the 3 over 2, which is this one and this one. 7 over 2 is what as a decimal? 3.5. So 14 minus 3.5 gives me what? 10.5. X raised to the 3 over 2. My very last grouping then is my x raised to the 1/2. So what's 1 minus 1/2? So plus 0.5 x to the 1/2. All over this lovely x to the 3 plus the square root of x squared. And there it is in all of its glory. Yes?
Would the 10.5 x to the 3 over 2 be positive because 14?
Yes, thank you. Is that it? It's the only one that I made a mistake on? That's actually pretty good for the amount of algebra we did. Yes?
You don't want us to times that by 2 to get rid of the decimal?
You can absolutely, so she said, do I need to multiply it by 2? Yes, we really should multiply everything by 2 to get rid of the decimals. Because we don't like decimals within fractions. So the question is, this decimal, and there's this decimal. Ideally, we should multiply everything by 2 to get rid of the decimals. So let's just take that extra step. And so it's going to be negative 14x to the 4th minus 4x to the 3rd plus, that is what, 21? X to the 3 over 2 plus 1x to the 1/2. Don't forget in the denominator you do need a 2 as well. We're just going to leave it outside of the parentheses. And there it is in all of its glory. Yes?
Do we need to expand the bottom?
No, because you love yourself.
Okay.
So here's the thing. Whenever you see the denominator in factored form, it is in your best interest to leave it in factored form because we always hope that something may combine out. That's what you always hope for. We have hopes and dreams. We do have hopes and dreams. Sometimes they get dashed, but we do have hopes and dreams. All right. Anything else? Cool. Please do H and E if you have not already done so. Okay, let's take a look at D.
Makes a lot more sense.
On D, I'm going to rewrite this as 3x to the negative 3, or negative 2. Because I'm using this rule that says, this is going to be helpful on your homework, if I have a to the negative n, this is 1 over a to the n. And so basically I'm right here, and I'm just going to rewrite it like that. It's equivalent, negative exponent. The other part is, sure, I can go just ball out of control and do the product rule, but if I can, I'm going to multiply through. If I can, I will, so I will multiply through. So when I multiply through, I'm going to get plus 45x to the 3rd plus 9x squared. And then notice I can take each term individually. So when I take each term individually, we haven't gone over this officially, but it's pretty much the same as we did when we had the derivative of x to the n. The derivative of x to the negative n is just, you bring that power down, and then you just subtract 1 from it. So h prime of x is going to be negative 6x to the negative 3. Because I'm taking the negative 2, multiplying by the positive 3, which gives me negative 6, and I drop a power, so I need to subtract 1, so it's a negative 3. And then plus, I'm going to do 45 times 3, which is, what is 45 times 3? 135. So 135 x squared plus 18x. How is that? Is that okay? Now, using that same kind of rule, because I don't want to do the quotient rule, if I can avoid the quotient rule, I certainly will. So I'm going to write this first part as x raised to the negative 1/3. negative because it's in the denominator. And 1/3 is I'm using this rule that if I have a, the A is the index of x to the m, this is going to be equal to x raised to the m over a. So I'm just writing the equivalent root as its power. So that's that part. Now the other thing is I'm going to multiply through again because I can. I'm going to go ahead and multiply this through. And when I multiply this through, I'm going to get plus, I'm going to have 1/2 x over the square root of x. And then plus 7 over 2, 1 over x, the square root of x. Do you all have any questions as to why I'm writing the fraction out front as a multiplier? Yes?
What?
So the reason I'm doing that, instead of writing this one here, instead of writing this as x to the square root of x, if I think of that 1 over 2 as being a multiplier, I can ignore it and just use it as a multiplier. It doesn't have to be a part of what I'll be doing in a minute. And what I'll be doing in a minute is I'm going to be using my rules of exponents that says it is going to be, let me erase that, this, if I subtract my exponents, this portion right here, this becomes x raised to the 1/2. So it's easier to do derivatives. So algebraic manipulation is going to be important on this to make our lives easier when we do derivatives. And then I'm going to write this as x raised to the negative 1/2. So what I really have now is I really have x raised to the negative 1/3 plus 1/2 x to the 1/2 plus 7 over 2 multiplied by x raised to the negative 1/2. And that allows me to do my derivatives easier without having to do any product rule or quotient rule. So if I can avoid it, I typically will. So when I do the derivative of the first one, that power is just going to come down as a multiplier. This will become a multiplier. So my function is what? F of x. So f prime of x, remember don't make this equal, f prime of x is now equal to negative 1/3 x, and I need to subtract 1 from there. So negative 4/3. And then plus, I have 1/2 as the multiplier. I need to multiply by this other 1/2. That's my power. And then x raised to, and I'm going to take 1/2 and subtract 1, which gives me what? Negative 1/2. So then, on the next one, I have plus 7 over 2. I need to multiply out by this exponent, so negative 1/2. And then x raised to, again, I'm taking 1/2 and subtracting 1 from it. Negative 3/2. How was that? Let's just clean this up now. I personally don't care if you leave the exponents as negative. So negative 1/3 x raised to the negative 4 over 3. If you want to write that as a positive, you would write negative 1/3 the cube root of x to the 4th. Personally, I leave it as it is. Then I have plus 1/4 x raised to the negative 1/2. And again, if you want to make positive exponents, it would have been plus 1/4 the square root of x. Personally, leave them as negative exponents. The last one is minus 7 over 4 x raised to negative 3 over 2, or minus 7 over 4 the square root of x to the 3rd. I'm good actually either way. If you had to do another derivative, if you had to do the second derivative, then you would probably want to leave it like this form because it'll make your life easier. How was that? Is that okay? Could be better, could be worse. Okay, so for this one, they're asking us to find the values of x for which the slope of the curve of our function is equal to 0. Now, back in pre-calc 1, we would have had to figure out where this thing would have equaled 0. Well, the only one we could have done in pre-calc 1 with the skills that we had was this one. We would have found the vertex, right? We would have found the vertex. We are not going to do that because we love ourselves. When you do derivatives, what does it mean when we do derivatives? What are we finding when we're doing derivatives? Slope of the tangent. We want to know where the slope of the tangent is equal to 0. So we just find the derivative and set it equal to 0 and solve, and that's it. So I'm going to find f prime of x. This is going to be 3x squared minus 27. That's the derivative. I want the slope to be 0. So I'm going to set this thing equal to 0 and solve. 3 is common between 27 and 3, so I can divide everything by 3, or factor it out if you want. So I have x squared minus 9 is equal to 0. Because I have an equal sign, I can divide every term by 3 without changing the function, the equation. Now there's factors. So what are my two values? So at 3 and negative 3, I have a turning point. I have a maximum or a minimum. Every time I have a turning point, I have a maximum or minimum, the slope of the tangent is equal to 0. So I can find the vertex of a quadratic faster than I ever did before by doing the derivative of it and setting it equal to 0. It's kind of cool. Too bad we didn't know that in pre-calc 1. All right, please do B and C. Okay, so somebody help me out with f prime on B. F prime is equal to what? 6x squared minus 6x minus 12. And then what do? So I set this thing equal to 0 and divide by 6. So x squared minus 6x minus 12 is equal to 0. Why are you dividing everything by 6?
Because it's a common factor. 6 and 12.
Why didn't I divide everything by 2?
Because the largest is the better.
Because the largest common factor is 6, so I'm dividing everything by the largest common factor. So I get x squared minus x minus 2 is equal to 0. Does that factor? What does it factor into? So x equals what? So 2 and negative 1. These are the turning points. In other words, these are minimum and maximum. If you get to the point where it does not factor over the reals, you do the first derivative and it does not factor over the reals, that means you have no turning points. That means the graph is always increasing or the graph is always decreasing on the entire graph. You may have some horizontal slides, but everything is increasing or decreasing. You don't have a max or a minimum. What we are chasing right now are maximums and minimums, the locations of them. We're chasing locations of maximums and minimums. All right, so you all multiply this together on C, yeah? What does it multiply up to? 6x squared, I'll start you out. Plus 6x? No? Plus x minus 1. Okay, so now what? What's my derivative on this? 12x. This is probably like the best one ever. Why is this one the best one ever? Because I don't have to really factor. 12x plus 1 is equal to 0. So x is equal to negative 1 over 12. That is the h part of the vertex. Check that out.
So that's the turning point? That's like a...
That is, in this case, it's because it's opening up, that is the location of your minimum. Yeah, look at that. Isn't that cool?
But not the turning point.
It's the turning point of the minimum. It's not the actual lowest value. It is the location of the turning point of the minimum.
So we're doing this before we get into extreme.
Yes, we're going into extrema. Woo! Isn't that cool?
Yeah.
We're excited. Okay. So we want, on these, we want the equation of the tangent line given at a point. So what I'm going to do is I'm going to find the derivative first. So I'm going to do y prime is equal to 3x squared minus 8x plus 2. What did I just find? Did I find the equation of the tangent line? What did I just find? The derivative. What does the derivative represent? The equation of the slope. I just found the equation of the slope. That's all I did. This represents the slope of the tangent. All I did was find the slope of the tangent. I didn't find the equation of the tangent line. In fact, this isn't a line. All I did was find the slope of the tangent line. So I need to find the actual slope. How do I do that? I'm going to plug in 2. So I'm going to do y prime evaluated at a equals 2. So I'm going to put 2 in there. So I have 3 times 2 squared minus 8 times 2 plus 2. So what comes out? So my slope is negative 2. So what I'm trying to do is I'm trying to find y equals mx plus b. That's what I'm trying to get to, is I'm trying to get the equation of the slope of the tangent at that point. What did I just find? M. All I did was find m. This value is m. Now what do I do? Plug what in? Okay, so I'm now down to y is equal to negative 2x plus b. Now what? How do I find b? We don't know. You know. Okay, so if I have the x value and I have a function, how do I find the y value? I plug it into the function. So we need to find y. Y is equal to, I'm going to put in 2 into my original function, so 2 cubed, and then it's plus or minus 2 squared plus 2 times 2 minus 1. So what is my y value associated with that 2? 3. Do you all agree? I don't know. I'm asking you all. Is it 3? I don't know. You all have calculators? I don't. Yes? Do you agree or disagree? Do you get a different number? Negative 5? Negative 5? Okay. So, now I have my ordered pair. What I'm going to use to get to here, to get to there, is I'm going to use this equation. Y is equal to m. X minus x1 plus y1. I'm going to put that information in there, and then I'll get y equals mx plus b. So y is equal to negative 2, x minus my 2 for my ordered pair, and then plus my y, so minus 5. So y is equal to negative 2x plus 4 minus 5. Y is equal to negative 2x minus 5, and that's my final answer. That's the answer I'm chasing. All the derivative does for me is give me an equation of the slope of the tangent line. So I still need to find my y, because I need an ordered pair when I have a slope. Oh yeah, I'm just seeing if you all are awake.
Glad I'm not going crazy. I was like, wow, this disappeared.
It was the snow. The snow did that to me. I was looking out there looking for snow, and it's not happening. All right, how was that? Yes, James.
If x equals a, could we just put 2 for x and if you get y?
Well, if you put it in this equation right here, you still need to find b.
Yeah.
So you can put so if you put 2 into this equation, you still don't have y and you still don't have b. So you still have to find another, you need that ordered pair to start out with. We'll see you all tomorrow.